Hi guys, today is the second in our video series where we're doing free stuff on Azure. Today we're going to be looking at two ways to run containers for free on Azure. So there's two services on Azure that will allow you to run certain levels of containers for free at zero cost to you. And you can use these to run most general purpose containers that are for different kinds of web-based applications or cloud-based applications. So we're going to look at what a container is and what makes them so great. And then we're going to look at a container workflow. And then we'll look at these two specific options and how you can run the same container essentially in one or the other one and talk about the pros and cons of both solutions. But let's just go through what a container is and why it works. And then we'll look at the actual technical implementation of this on Azure. One good way to explain containers is to compare them to something that's pretty familiar, and that would be virtual machines. So with virtual machines, you have a stack that looks like this. You'll have physical hardware, you'll have a host operating system, then you'll have a hypervisor. The hypervisor then provides virtual hardware, and then on top of that virtual hardware, you can install a guest operating system, and then you can put your apps on top of that guest operating system. So this one provides essentially virtualized hardware and is doing the virtualization at that layer right here. Now, containers take a similar approach, but they move the virtualization abstraction to a different layer up in the stack. So in this case, we still have physical hardware, we have a guest operating system, and we have a container runtime, which is analogous to a hypervisor. But instead of providing virtual hardware, it provides what I like to call a virtual kernel to containers. So instead of having virtual hardware that needs a guest operating system for the apps and binaries to run, you can just use the virtual kernel, which gives you just enough operating system to allow the apps and binaries to basically just run on top of the container runtime. So the apps and binaries will have all the stuff it needs to run the app, but then anything that is going to be more OS specific, it's going to be able to call into the virtualized kernel in the container runtime, and then it interacts with the host operating system. So that's basically the trade-off between a container and a virtual machine, is because this is providing a virtual kernel. A container is OS specific, so it has an operating system affinity essentially. So a Linux container needs a Linux host to run. A Windows container needs a Windows host to run. But usually that's not a problem for containers because you're going to be targeting either a Linux environment or a Windows environment, depending on which kind of container you're using. And then everything needed to run the application is self-contained within the context of the container that is running it. And so this allows us to have better application density on the same physical hardware that you would otherwise have to use for guest operating systems and apps and binaries, because this adds overhead right here that this can eliminate by doing that trade-off between abstracting at the kernel versus the hardware. So let's look at the container workflow, because this is important to understand how containers go from something like a dev environment to a running application. So this basically works using Docker. And if you've been around containers, you've probably heard about Docker, but there are many container formats. Docker is the one that most people use and is probably the one that people are going to be most familiar with. So you start off with a local dev environment that is running Docker. So the Docker daemon is running on the local dev environment, and you start off what is called a Docker file. The Docker file is just essentially a script that tells Docker how to build an image. So it usually starts with a base image, and then it will have some instructions in there to move data into or files into the build environment. And then you can run commands on that Docker file that will execute instructions for basically pulling down binaries, for configuring software, and doing all the stuff that is defined within the context of that Docker file. So the Docker file has the instructions. So then you call Docker build, and then that runs, and it basically creates a container image. Now the container image itself is not a container. It's just the basic image format that contains all of the files needed to create a container. So a container image can be used to create n number of container instances from a single container image. So once that container image is built, you can take that and run it locally, or you can push it up to a container registry using Docker push, and it basically just copies the container image over to the container registry. Now, container registries are basically just repositories for container images. So you have one or more container images on the repository. And then those repositories are accessible online, so container runtime environments can download those images and run them. So there are a few out there that you can use for sure. One that is free is Docker Hub, and they provide a free container registry for your personal use if you want to use it, or you can use Azure Container Registry. Since we're talking about free stuff here, I'm not going to be using Azure Container Registry. I'm just going to be using Docker Hub for my container images. So once it's up on Docker Hub, then you run some command that will take the container image and deploy it to your container runtime environment. So that could be any number of different services on Azure. So that could be something like app services or container apps, which are the two free services I'm going to be talking about. Or you could run that in Azure Kubernetes services. You can also run it on container instances. You could run it on OpenShift or Service Fabric or many of the other services that are available on Azure. But these two allow you to run apps for free. So you run some command that basically runs the container. And that will then download the container image from the container registry into that local runtime. And then it takes that container image and spins it up as a container. It could be one container or two containers or n number of containers, depending on how many you need for your application. But this workflow is very similar regardless of whether you're working in dev, you're using public or private registries, and it really doesn't matter if you're using container apps, app services, or Kubernetes or whatever. They all basically work the same way with building an image, pushing it to a container registry, and then running a command that will then pull it down from the registry and run it in whatever container service that you might want to be used for your application. So here is this server that I'm going to be deploying. So I'm deploying the same app that I deployed in my first video. I'll link that in the video description down below so you can watch that. It's basically just a client server application built using the mean stack, which is MongoDB. It's using Angular front end. It's using a Node.js backend with Express being the web server. And so one thing you can do with Node.js applications is deploy them into Docker containers and deploy them to any environment that can run Docker containers. And so this one is already set up with a Docker file that I can use to build that image with. Now the front end, again, I can deploy with a Docker image, but I'm going to actually still use Azure Static Web Apps for that because it's a great source for deploying apps on Azure for free. And it will actually take some of the load off the backend APIs if I do that. So I'm just going to put all the content out on static web apps and then point it to the backend service that's going to be running in a Docker container. And that will allow me to actually use this for my API, which is written in Node.js, and then use the front end that's just static HTML, which can run in a browser. So let's look at this Docker file right here. And let me open this up with, say, Notepad right here. You can open this up in any text editor. But this is just a basic Docker file. This is pretty typical of any Node.js application. If you were to look at most builds for Node.js, they're going to look very similar to this. And this is just the base image that it's building from. So it's using a node-based image and basically setting a working directory. It's copying up the package.json, which just is a file that contains references to the libraries that this app needs, the dependencies. It installs the dependencies. It copies the rest of the app up into the folder. And then it says, build the application if it needs to be built. And then from there, it takes that and then sets a command to run this. And it's just calling node and then pointing it to the root, which is the server.js file, which is the root for this particular server right here. So very basic Docker file, but it builds. And then once I have that image, I can then push this up to a registry. So to do that, I'm going to close this out right here. And I'm going to pull up a command prompt. So this is already in the folder. So if I want to build this, I need to have a Linux context to build this image because I'm going to be deploying this to either a Linux host on Azure App Services or on Azure Container Apps. So both of them can run Linux containers. So that's why I'm targeting Linux. So I've SSH'd into my Linux box that has Docker already built onto it. You could use Windows Subsystem for Linux to build this. I use this Linux box mostly because it's dedicated for Linux and I can do all kinds of stuff on it as well. So I've SSH'd into the box. And so I'm going to build this particular file container image just using some Docker commands. So to build it, just do docker build dash dot like that. And I'm already in the folder and it's just going to reference the actual mean stack right here. So this is telling it to look for the Docker file in the local folder. That's just the dot. And then I'm tagging it with a -t blaze/mean stack. And then that will build it. Now this is building really fast because it's using image caches that I have in my local environment. But if it was going to take longer, you would see it run through the script because I've already built this. And once you have that built, then you can run a push command that looks like this. Now the push command is going to push it up to Docker Hub. I've already pushed this, so it's going to basically to say layer already exists, but that would actually take the built image and push it up to Docker Hub. Now Docker Hub has the image now. Now it's ready to deploy to the environments that I want to deploy in, which are Azure App Services and Container Apps. I'm going to deploy it to both and then just reconfigure my app to point to one or the other to show you how these work. So here are the resources for this particular demo that I'm using here. I have already deployed all this. I talked about how to do Cosmos DB in my first video, and I'm deploying MeanStack, and part of that is MongoDB. So I use the Cosmos DB for MongoDB there, and I've already talked about how to do that. I also have a static web app for the front end, the Angular front end. So I've talked about how to deploy that already as well. So I won't be going into that. I'm mostly concerned about the app services that I'm using to host a container, as well as the container apps. Now, I talked about app services in my first video from the context of the native offerings on app services, but you can also use it for containers as well. As long as it's a web-facing container, you can use it in the context of app services. And container apps is a little bit more robust in what you can run in this context. It can run web-facing containers, but it can also run other kind of backend containers as well, depending on what you want to do with the containers that you're using. But in this case, I'm using a web-facing container that is running basically an API written in Angular, not in Angular, Node.js, that is running with Express as the web server. So let's take a look at this deployment. It's pretty straightforward. So if I do a web app for containers here, I should get a link to that if I search for it. And the web apps for containers, it's taking a little bit to find it. There it is. Web app for containers is distinct from container apps. The branding is a little bit confusing, but if I create this, it's actually creating an app service plan and an app service that will allow me to run a container. And so in this case, I can choose the tier that I want to use or the app service plan. I already created one. If I created a new one, I could create a new one, and I can choose the free tier for the hosting. But in any case, I'm going to be using a Docker container, and I'm going to choose the Linux for the runtime. And for the configuration on this, what I mostly need to do is choose a single container. You can also use Docker compose files. I'm going to use Docker Hub, and then you can use public, and then you put in the name and the image repository and the tag that you're going to be using. In my case, it would have been blaze/meanstack, which is what I pushed to Docker Hub as a public image. And that will then pull the image down into app services and run it in this free context right here. I've already done that, so I'm not going to repeat that, but I'm just going to poke around inside of this, not inside this one right here, inside of my app service right here. Now you can see that it has a front end right here. It's got the, that's the URL for it. It's using a free app service plan, and it's got just a basic configuration at this point. I don't have any scaling or anything like that turned on. It's just basically, here are the settings for it. And if I wanted to scale up the app service plan, I could do that as well. Now, this one that is using the container image right here. And if I want to configure the container image settings, basically the environment variables that in the containers, that's where I go to the configurations right here. And all of these get injected into the container as environment variables, and they can be read from the environment using whatever programming language you're using. And so this is the connection string for my database, and this is the port it comes up on. And so basically it reads the port, and then that's how Node.js knows what port to start up on. Otherwise, it just chooses a default for the port. Now, of course, these are other settings that you can do. You can scale this up if you want to do that, or deployment center. This is basically how you can configure the image that you want to change. If you want to change the image, you can do that, or change the container type. If you want to use a multi-container build, basically a container with like a sidecar or something like that, that's what Docker Compose will give you. And you can use custom repositories like Azure Container Registry, or you can use Docker Hub Public, which I'm doing here because it's free. Or if you want to, you can actually build the image in Docker Hub and have it in GitHub Actions and then have it pull it using this to pull it down from that as well. So there's a lot of ways that you can deploy to this guy, but I'm using just a Docker Hub image, which I've already pushed, which I showed you that already. So this is my first instance, which is basically running in app services. I have something very similar with that going on inside of container apps. I'm going to do container apps here. Let's go ahead and pull that up. And container apps is another service that is useful for running containers. App services is mostly aimed at one or two containers that will scale up to multiple instances of it. Container apps is a full-blown runtime that allows you to have more complex applications where all the parts of the applications are running in containers. You can use it to run a single container, or you can have apps that have multiple parts that are running like microservices across a bunch of smaller containers. So this gives you several, about 5 hours of runtime that you can use, and you can scale to 0 if you want to in this, so you're not accruing against those credits that it gives you for the free offerings that are available in this, and that's why this is a free service. And so within that context, I can set my app to scale to 0 if it's not being used. And so if I wanted to create a free app right here, I can create a new container app right here. And this is just going to give me some kind of name, just test env. This is for my container app environment. And I can create this one and then have it integrated with a virtual network if I wanted to. But the basics are there. And once you create the environment, it will have a certain amount of credit that you can use for your container app. So this creates a container app environment. And then this creates the container app itself. And this is where you can also choose one of the defaults. You can use a quick start image, or you can use a Docker Hub image, just like we did. And you can put in, like we did already with Blaze mean stack. And that will just pull this image right here instead of using a private repository or an Azure container registry. This allows you to select the CPU and memory. It basically divides out the number of CPU seconds, I think is how it's measured on this particular app. So it gives you so many CPU seconds, and then also the so many memory seconds that you can use. And I'm using a fractional CPU and a fractional gigabit right here for this particular container because it's pretty lightweight. And of course, you can set environment variables and set ingress right there. And ingress is what you would want to turn on if you had a web-facing container. So once you deploy that, you end up with something like this. You have a container app environment, and then you have a container app. Container app is where the magic happens, and this is just basically the place where my container is running, but it's running in that container app environment. If I had other container apps running, they would all run in the same environment, but they would each use different containers, and they can talk to each other over what is essentially a private connection. And you can also use some other things in this, like Dapper and identity and different kinds of things to make this a more robust feature set. But for my purposes, this is probably going to be just fine here. And so I'm getting an error here because this has a path mapping. If I had to pull up employees right here, it's going to give me a list of employees. Basically, it's just querying that against the database. And so that tells me it's running right there. And now if I did the same thing on my other app, what we just saw right here, my app service, if I pull this one up, I'm going to get the exact same list because these are hitting the exact same database. And getting the exact same list of people. And it's because it's running the same code, the exact same image, in fact, and it's hitting the exact same database. I just have one running on app services and one running on container apps. So let's hit this from the front end using both and just see how it works. So let's run this in a new browser window right here. I'm going to pull up a new debug console so we can see what's going on here. This is the URL for the static web app. And we can see here on the network tab what it exactly called out to. So if we looked at the employees right here, it called out to this particular host right here, which is MeanStack. This is the container apps instance of this. So this right here is calling out to this one right here. This is the container app. So that's how I have it currently configured. And so this static web app is running in my browser right here, and it's calling out to my container app instance of my MeanStack, and then it's hitting Cosmos DB under the hood. And so let's do a new change here. I'm just going to call it, let's add another employee. Let's add in John Thompson. And he is the Chief Executive Officer for Atmosera. And he's a senior, of course. And let's add that one in. So we have 3 employees in this list. Now, I would expect to see all 3 of these if I reconfigure the application to run against my instance that is running in app services. So let me reconfigure this, and then I'll come back with the reconfigured app running there, and we'll see it run the same thing. It's going to be identical, except the only difference is instead of calling out to our container apps version, we'll call it to the app service version. So I've reconfigured the front end app to now talk to the app service version. So I'm going to go ahead and just drop the same URL in here. Now let's get up a debug console here, and let's just basically reload this again, and let's see if we got a network here. Now there is the employees XHR, which is the request it made against the Azure website, which is the endpoint for an app service. So that is my mean stack app service right there. It's just running the container. And I can add a new employee here. And I could say, let's say Jacob Saunders, who is our VP of professional services, I think is what we call the division now. And of course, senior. And we have now 4 entries in this. And it's basically pulling that data from that Cosmos DB database using a mean stack behind the front as the API, and then of course using Angular for the front end. So again, this is just a couple of ways that you can run containers for free on Azure, and you get very similar results. And depending on what your context depends on which one you might want to choose. But in any case, it's just another way to run free stuff on Azure, another great way to learn about how to run stuff on Azure.